Today I will present you findings of 4 different papers I've been working on in the last 5 years. And I start with this observation, as I told you, that actually ESG ratings disagree wildly. And you might have heard of ESG ratings, probably because that's why you're here. But let's give you a little bit of overview. So 5 years ago, we downloaded the 6. We started with 5, but then we ended up with 6, the 6 biggest raters, and just looked at the ESG ratings. And we normalized them and then graphed them. So here is an extraction of 2 subsamples. On the left-hand side, you have the subsample where the ESG raters agree the most for 25 firms. And on the right-hand side, you have the subsample where actually ESG raters disagree the most. So you see a lot of disagreement, but also a lot of disagreement. And it's actually quite big because you have it, sometimes it goes up to 4 standard deviations difference. That's really massive. That means one rater says, this is a great company. Another rater says, this is a very bad company in terms of ESG. We also see when you look at those companies, for example, on the left-hand side, you have Morgan Stanley, you have Apple. On the right-hand side, you have Barrick Gold, AT&T, you have Johnson & Johnson, you have Intel. There's also, I think there was a bank somewhere, Bank of America. So it's not really explained by industries. It's not really explained by size. Actually, we couldn't really explain this divergence. So we thought we have to dig a little bit deeper. So we downloaded the raw data, and hence the name Aggregate confusion, because there was a lot of aggregation in all senses. And then we were really confused. And now I want to talk to you. But what's so interesting about these ESG raters, they all are built or constructed in a similar way. So they're all weighted averages of a certain set of indicators. And the weights differ often between industries. And they feed into one ESG rating. And here you have, on the left-hand side, you have rater 1, and on the right-hand side, red dot is rater 2. In the middle, we actually, this is something that we actually allowed us to compare those raters and disentangle why they disagree. We have theoretical attributes. Theoretical attribute would be something like the true CO2 emissions of a company, not the self-stated ones, the self-disclosed ones, but the true ones that probably no one knows and no one would probably ever observe. And with discrimination, there's something like a true discrimination performance within a company, but most likely we will not observe it, just for the reason that we don't even want to observe it, because if we observed it, we would need to put like sensors on everyone and record every interaction and non-interaction inside and outside of the company. And that would obviously create privacy concerns. So yeah, it's just purely theoretical. So each rater then chooses how to actually measure this theoretical attribute with an indicator. Discrimination, you just use proxies, right? Because it's easy. So the difference in salaries, for example, or you could look at harassment cases. You could also combine the two and then come up with an indicator. CO2 emissions, often scope 1 and scope 2 CO emissions are disclosed, but scope 3 emissions are not. And so they're estimated. And so that would also fall under then the measurement. And so there we have a measurement divergence. Then, not every rater assesses the same attributes. For example, having grown up in Germany, I know that electrosmog is a big thing here. When I moved to Cambridge in the US, I have a landline just next to my bed in the street. Every German would go crazy. I did. And so that is something that then ESG raters most likely in the US wouldn't assess. For example, also the French rater, Vigeo Eiris, that became Moody's now, have a lot of labor issues in their assessment, whereas MSCI, which is more American-centric, doesn't have that much labor issues. So that's why we have a scope divergence. And last but not least, raters, in order to aggregate those indicators that they measure, they give it a different relative importance, those weights I was talking about. That's what we call weight divergence. So, and this is actually fairly similar for all raters. And I will show you that actually this is even more true than the raters would like to tell you. Let's go back a little bit to the headline correlations. So here we have our sample of 6 different raters, KLD. KLD is a tricky data set. It's been around for a very long time, and it's actually phased out. It belongs to MCI. We have it in our analysis because a lot of academic research is written using that because it's free on Words, the big database. Yeah, and so we just want to show how it compares to the other ESG raters. And we have Sustainalytics, we have Moody's, we have S&P, we have Refinitiv, and MSCI. Those are the 6 raters. And what you can see is that for the ESG rating, correlations range from 0.38 to 0.71. So they're somewhat correlated, but not perfectly. So there's surely disagreement. And interestingly, so the average correlation is actually 0.54. So what's interesting is that actually when you go a little bit deeper into the different dimensions, the correlations drop. And this is a result that has been shown in other papers then. And they all find, basically everyone finds the same, that the environmental dimension has the highest agreement, followed by the social dimension, and then by the governance dimension, which is interesting because governance has been around for a very long time. We should actually be able to measure it, but maybe that's also the reason why we diverge so much. Might be that SE is just everyone just uses the same data, and that's why the correlations are higher. Unfortunately, we couldn't find that out because when we contacted all those ESG raters, they were really reluctant to give us actually an explanation what was in those raw indicators and what data fed into that and how they actually constructed the measurement methodologies. Yeah. So in order to make actually now compare those different ESG raters, we needed to create a common language, a mapping of the indicators onto each other, or a common taxonomy. And what helped us here is this idea of everyone tries to measure this theoretical attribute and then coming up with an indicator. And here, so we looked at all the different indicators from the raters, and they go from 38 for Moody's to 282 for Refinitiv. Huge variation in the amount of indicators. And so here's an example for the water category. So the way we did it is that whenever two raters had at least one indicator in an attribute, we created this category, the category, and then just mapped all the raters on it. And here, this is water. Water is, everyone has an indicator for the category water. Refinitiv has 3, ALE has 2, MSCI has 1, Moody's has 1, Analytics 2, and S&P Global has 2. And there's indicators in that, like water stress management, water operations, water-related risks, discharge into water systems, water recycling, water use. So now you see there are actually several indicators per rater in a category. So what we did is we just took a simple average. That wasn't our initial idea. We actually used fancy nonlinear machine learning techniques such as neural networks, random forests to create those categories, clustering, all sorts of stuff. Turns out actually that good old, very arithmetic, simple, equally weighted average is actually good enough. And I will show you that on another slide. Okay, so we did that actually for a lot of categories. So it was a lot of work. Also, I burned through a lot of research assistants, unfortunately. Um, and and they were very helpful and they were great. But it took us really a long time, and we had like 64 categories in total. So again, to sum it up, we have three reasons because we disagree. Those ESG raters disagree. First is scope. That is, do I measure something? Do I assess an attribute or not? Then we have weights. What's the relative importance? So is lobbying more important than climate change risks or not? And then measurement, divergence. That is, when I assess the same attribute, or two different raters assess the same attribute, they come to different conclusions because you use different inputs and different assumptions. And even there's human bias. Ah. Eh. Okay. So now we have this common language, so the 64 different categories. And now we can actually compare those categories between raters. Here I show you actually a robustness check out of the paper. And the only reason is because we also map all that on SASB. So in the SASB categories, and they're far less. I can actually show you it on the slide. These four categories would be just a little bit cumbersome. So yeah, there's just no difference. Actually, the results are very much similar. Actually, even undistinguishably similar. Yeah. So what we did here is we compared two different raters, so it's pairwise correlations for each given category. So for example, the correlation between KLD and Sustainalytics for access and affordability is 41%. For air quality between Sustainalytics and Refinitiv is 0.27%. So you see, nothing is really 100%. That means there's measurement divergence. We all try to measure the same thing, but they disagree. You also see some blank fields. Since it's a pairwise comparison, it means that at least one of the raters of the two doesn't have any indicator in that category. So we have a scope divergence. And what's also so interesting is that the correlations are all over the place, even negative. How can that be? Negative means one rater thinks this is a good company, and the other rater thinks it's a bad company for that topic. For example, here, for selling practice and product labeling, it's like responsible marketing. For example, if a tobacco company targets young adults in the ads. So KLD thinks the companies are great. Sustainalytics thinks the companies are bad. Obviously, that looks like I made a data error, but I can assure you, I checked 5 times. It's not. It's even worse. There's actually, in our 64 categories, we have unambiguous indicators, such as CEO and chairman separation. That's observable. Everyone knows that. You could go into the financial report of a company and you would see it. And still, the correlation between Refinitiv and Sustainalytics is only 92%. And I will show you in a different paper later that actually Refinitiv gets it completely wrong. For example, Volkswagen is not flagged as a signatory of the UN Global Compact until a year ago, even though they signed more than 10 years ago, and it's what used to be one of the biggest companies in the world. Okay, what's interesting is that here we have one column where almost everything is very green, so there are high correlations. Actually, it makes sense because MSCI bought KLD, and KLD is just a mapping on MSCI. So yeah, a lot of measurement divergence and also scope divergence. Now we have to look still at the third source of divergence, and that's weights divergence. And here, actually, in this exercise, we not only look at weights divergence, but we also want to prove that actually this taxonomy is actually a valid construct, that actually we can map those indicators onto each other, and we can just take the simple average, and it's still a very good construct. And even worse, as I said, those weights for those indicators that then aggregate those indicators into an ESG rating, they depend on industry, and that's something that you hear everywhere. Materiality, that's the word, right? Turns out that's actually not that true when you run some statistical analysis. So what we did is a reverse engineering. So we used the original rating of each rater and regressed it onto their own data, but through the lens of our categorization. So, and what you see then is actually, if I explain a very high amount of that variance, right? So when I explain a very high percentage of that ESG ratings, then I know that that I can work with it. Then this is a valid construct, as I said. And you see, the measure here, for goodness of fit, is the R squared. And when I regress Sustainalytics on its own data, then I have an R squared of 87. So that's actually really fairly high. And again, I do not look at all the firms that have the same weights in different in different industries. For S&P Global, it's even much higher, 98%. For Refinitiv, it's 92%. For Moody's, it's 96. For KLD, it's 98. Only for MSCI is a little bit lower, 76%. And when you zoom in here in one industry, like the banking sector, for example, then the R squared goes up to 99%. So MSCI depends a little bit more on the different industries than the others. So hence we conclude that we can actually work with that data, or with our assumption that with that categorization. The other thing here is that you see there's weight divergence, because you see that weights are not the same. So the coefficients. Also, just before I say that, this is a linear regression. So on negative least squares, so we force actually the coefficients to be positive, because we know they shouldn't be negative. And that doesn't change anything of the explained variance, so they are squared very constant. And also we use actually non-linear machine learning models, meaning models that actually could take into account, they would detect if there's a difference between the industries. Turns out they can't. So yeah, the linear model, the simple linear model is our model of choice. Makes it also much easier to interpret and for further analysis. So let's look at the weights. Business ethics, for example. See a weight of 0.12 for Sustainalytics. S&P Global 0.059. For Moody's 0.186. And for KLD even 0.273. There's a huge weights divergence, as you can see. And this is the third source of divergence. Scope, weights, and measurement. So let's talk about the results. Obviously, there are a lot of steps now that we actually detail in the paper, and I'm happy to discuss that. If anyone has a question, please send me a mail. But it's very detailed in the paper if you're interested. But our findings are that the biggest source of disagreement divergence between those ESG raters is by far measurement. How do I measure something? Do I choose rather sexual harassment cases for discrimination or the difference in salaries? How do I estimate my scope 3 emissions? And in case the company discloses already scope 1 and scope 2 emissions. That is often not the case. And the second source of divergence is scope, 38%. And the last is actually very small, is weights divergence, the relative importance. And the implications of that I will talk about at the end of the talk. But we actually investigated the measurement divergence a little bit further. And we found something what we called a rater effect. Also in the literature, sometimes it's called halo effect. It means those ESG raters, the ESG analysts, they're often organized by company, not by subject. So one ESG analyst has like 10 companies in their portfolio. And for example, for Refinitiv, 282 different indicators that they have to assess. Personally, I think it's very hard to be a specialist in child labor issues, human rights issues, lobbying issues, climate change issues, governance in general. So what we find actually statistically is that the overall view of the company shapes the individual assessment of each indicator. Example, remember when you were in elementary school, you most likely had in every class the same teacher. And assume that of the 7 classes you had, in 6 classes, really good, the head of the class. But in the last class, you really hated the class, you didn't study for the test, and you got an average grade, and you deserved it. The teacher doesn't know that. So most likely he will give you a grade that's better than the average because he thinks you just had a bad day. And so this is a little bit the example of a halo effect. Yeah. Okay. So this measurement is obviously a big issue. And this measurement divergence also implies that we don't really know how to measure those indicators or those ESG ratings. We don't know how to measure them perfectly. So there's a lot of measurement noise and error in there. And that obviously is a problem because measurement error makes it really hard to detect actually or to use the ESG ratings. You have something like a attenuation bias. It's a little bit like this. Now you can hear me better, or yeah. So this is a little bit the same thing, right? So when you run a regression of stock return, what we famously do a lot in academia, on ESG ratings, then the effect will probably be smaller because of that measurement noise, certainly smaller than it should be. So the easy way out is you buy 8 different raters, you take the average. That's what you learn in high school, and that is that's actually a good start. But turns out the average is not great when the errors are distributed in differently. And so ESG raters create the ESG ratings differently. S&P Global is famous for having one questionnaire, sending that out to each company, and really assessing this what they think what the ESG performance is. And they do that once a year. It's like a really fundamental assessment. On the other hand, you have raters such as True Value Labs that think that is way too slow moving, and so they introduce a lot of variability, daily variability, web scraping all sorts of information that they can find on the web every day. And they give you a different score for each company every day. You can see the True Value Labs rating will be more reactive to new news, but it will actually also come at the expense of more measurement error. It's a little bit further away from whatever the true ESG performance is. And this is exactly what we find. So one way out of this problem with the different distributions of errors is instrumental variable regression. So as I said, most of the time in academia, we look at this regression, stock returns on ESG ratings, some financial control variables, fixed effects, whatever you like in that regression. And what we do here is actually we insert a first stage regression. We take this ESG rating, let's say MSCI, and regress it on other ESG ratings, on 7 other ESG ratings. Then we use the Y hat, so the predicted value, or the instrumented ESG rating, inserted in our second stage regression, which is the stock return on ESG rating regression. Now, since we kind of stripped away the noise from the MSCI rating, the coefficient in that regression should go up. And we do see that. It goes up by a factor of 2.6 in our sample. So we have actually, we have 8 different raters in this sample. It goes from 2014 to 2021. The problem here is obviously that a lot of ESG raters don't have any data before 2014. So we have a very short time series, which has certain applications I will talk about later. And we do that for 4 different regions. We do that for the Eurozone, the pound, the yen, and the dollar. And so what we do is, in order to figure out if actually there's measurement error, we use the standard setting, so the normal, the OLS, ordinary least square regression of stock return on ESG. The coefficients are here. And then we do the instrumental variable approach, where we actually instrument the ESG rating. And as I said, if there's measurement error, then the coefficient in absolute value should go up. And what we see here, I will just zoom in the Eurozone. We have the all coefficients are positive here. Doesn't matter if they're positive or negative. As I said, in absolute value, they should be bigger for the instrumented. And what we see is not for the first one, but for the second one, the coefficient goes up. For the third one, the coefficient goes up quite massively. For the fourth one, the coefficient goes up. Here, for the sixth one, the coefficient doesn't go up, is also not significant in both cases. Sustainalytics, it goes up. TVL, it goes up massively. And that's why I actually also talked about true value labs, because they have this daily variability. They're very noisy, have a high measurement error. Moody's also goes up quite a lot. And you can see even statistical significance is so-so with the OLS, and then it goes actually up with the instrumented variable approach. And the picture is sort of similar or it is similar for the others. And we also we test for that statistically, that this is actually really what's happening. Very much detailed in the paper. It's very long. I'm sorry for that. But if you're interested, yeah, please read it. So those boxes here actually show we also have to test if actually the other ESG raters, when we instrument one ESG ratings, are valid instruments. And there are a certain set of assumptions, which I will not really get into because it's very technical. But as you can see, most of the time we use all the other ratings as instruments. That means all the other ratings actually do have important information. They contain important information that you can use in order to reduce the measurement error in each rating. So now I said the coefficient goes up, link goes up by a factor of 2.6. That's obviously very strong. And I also we have calculated the noise to signal ratio. It's a little bit implied. It's the other side of looking at it. And we see that the average, overall average is 61%. Or almost 62%. That's actually the noise contained in ESG ratings. Now, what's so interesting is, and why I'm so confident actually that those findings, are, at least in the statistical sense, true, is that we actually, so if you run the regression of 1 month ahead stock return on ESG ratings, and then on 2 months ahead, and then on 3 months ahead, and up to 8 months ahead, the coefficients change, and we can see that. But the noise to signal ratio is extremely constant. It always hovers around 60. So that for us, and the coefficients change, we show that in the paper. So that's why I think I'm very confident that this noise to signal ratio is very much Yeah, true in the statistical sense. I'm confident. So what I want to say, yeah, there's obviously a problem. So the time series is very short. And what we do in finance in order to actually find causation of an impact of ESG ratings on return is we need a certain length of a time series in order to run certain statistical models that we can actually exclude any other omitted variables. We cannot do that here, but mathematically we derive that in the paper. It is actually the omitted variable bias cancels out. So that's why this paper is not about the impact of ESG ratings on stock return. It's about the noise contained in ESG ratings. It's a bit different. And this omitted variable bias can be, for example, management quality. So a better management quality would then have as a symptom, for example, better ESG performance. It's also really hard to disentangle them, because maybe they're also the same, right? So I don't want to get into that discussion. The other thing is the inflows, and I will show you that in another paper. If actually we in the presence of a massive preference shift in the financial markets, these inflows into ESG funds is massive. So obviously that will change prices, and whatever changes prices will also change returns. And so maybe because we just look at the last 6-7 years where this preference shift is happening, we actually capture that. And this is why I'm saying it doesn't matter for this paper if the coefficient is positive or negative, right? Because if this is true with the preference shift and this preference shift levels out at one point, then those ESG funds, ESG stocks should have lower expected returns in the future. And that's something we can talk about in the panel discussion later a little bit more. I think this is a very important implication. Also, we're having impact in the ESG space. So now something more interesting for investors, because what happens actually, what is the difference between the instrumented ratings and the original ESG ratings? And you can see, because when you're an investor, you create a portfolio. What you often do is you keep the laggards. No, you keep the leaders, of course, unless you're a vice fund. And you keep the leaders, and you reject the laggards. And here in the fifth quantile, so this is the original rating, this is the instrumented rating. More than 40% would actually be not in your portfolio if you had used this methodology to reduce measurement error. That's a massive amount. It's almost 1 out of 2 companies. Yeah, same for the lowest, this was for the leaders, and this is for the laggards. Same, roughly. And if there was no measurement error in those ratings, you would have 100% here everywhere. Yeah, so I think that's a bit more the practical findings. Okay, now we talked about measurement error of if you want to assess, for example, an indicator such as CO2 emissions or anything. There's also maybe a funnier way of committing measurement errors, and that's just running a database that has problems. And one of the biggest actually ESG database that's also heavily used in academia, because again, is almost accessible in every library, probably also here, is Refinitiv. We actually, for a project, we downloaded the data for Refinitiv going back to 2010. And then we had a problem with the data, so we downloaded it again a couple of weeks later. Correlations wasn't 100% for the data we had. That's odd, because I mean, for 2010, the rating for Volkswagen shouldn't change, right? Oh, do you have new information 10 years later about Volkswagen? Apparently, Refinitiv has new information. And so downloaded it 3 times. Here, the difference is 2 years for between those two. And then between those two, it's just 2 months. Same company, completely different ratings, even for 2011. And it's not even like a rescaling, right? You could maybe say, oh, everything is multiplied by 2.5 because they want to change scale. Statistically, that doesn't make any difference, right? I wouldn't care as a researcher or as an investor. But here, even the slopes change. So the variability, the variance changes of the time series. That's completely different ratings. Obviously, we had to investigate. And yeah, so we downloaded a couple of times, actually 80 different times, sadly. Yes, I'm paid for that. And we found actually when we then use this data, when we use those ESG ratings, and we insert it in this typical regression that we run of stock return on ESG ratings that I showed you before, the newer the download, higher the correlation. They're also like, it's really the control variable is really the typical then asset pricing panel regression to assess the link, and it really goes up. That's obviously odd. So we investigated, and as I said, there's this UN Global Compact signatory, so that we can actually match with the database of the UN Global Compact, because the database of the UN Global Compact is a website, and it says exactly when a company actually signed the UN Global Compact. So there's no question. There's also, it's really impossible to make an error. Yet Refinitiv does make errors, and that so in a download between 2018 and 2021, we found 250 corrections. One, for example, was Volkswagen, and they had signed the UN Global Compact 10 years ago. Now the question is, why do they do that? Do they just have sloppy data work? Or do they really want to maximize this return? Because here with those ESG raters, we are in an investor pay model. So basically, you as an investor, you have to spend money and buy those ESG ratings. Credit risk rating is actually different. It's an issuer pay model where the company actually pays Moody's, Standard & Poor to create a credit rating. But here it's the investor. And the investor, what is he interested? Obviously not saving the world. He's interested in financial return. That was a cynical comment, but most likely that's the case. And I will show you proof for that later. I wouldn't say it just like that. And this is hilarious because this is a 6 weeks difference. So this is 2 downloads and only 6 weeks difference. And 4% of the companies that we have in 2011 have a change in raw data items. In just 6 weeks. I don't even know how to come up with new information 10 years ago. ESG ratings, even 80%. I mean, obviously, I showed you there's a lot of aggregation, and Refinitiv is a little bit of a prime example of a lot of aggregation. So there's a lot of rescaling, re-rankings, and renormalizations going on. So that's why you have actually quite a lot of changes, meaning one company in one industry changes, all the ratings for all the industry change because it's relative. Yeah. A journalist contacted them and asked, "You found this paper. What do you say about it?" "Not true," they said. It's like, what's not true about it? We can't say. So they refused to comment actually on it. But so far, yeah, that's what we find. We stand by it because I mean, we all download it again 80 times, and it's 80 times the same thing. Yeah, and so there are actually, and there are different ways of changes. There are massive changes, and those are methodology changes. There was one in, I think, 2014. I'm probably lying here. There's also one in 2020. And there, everything changed. But there are also weekly retroactive changes. And this, again, there was no methodology change here in between. So it's really, if you download it today, and if you download it, it's every Friday that it changes. If you download it again on Saturday, you have different data. And that creates a lot of problems. Also, it makes peer reviewing very easy. Now let's talk about the economic impact of ESG ratings. That's my latest project. And here we look at actually that's also the title of the talk. That was actually also the initial planning. As Laura said, we had just a academic seminar planned. Now it's more all my work together. And so here actually we look at MSCI ESG rating changes and their influence on mutual fund holdings and also on returns. And what we find is that when these MSCI ratings change in the US, a mutual fund change their holdings, ESG mutual funds. Not really a surprise. But the surprising part is it takes up to 18 months. If I believe that MSCI ratings are a source of overperformance, would I wait 18 months? Probably no, I would do it right away. But here it takes 18 months. And having worked at a big asset manager and now talking to other asset managers, anecdotally, this is true. So ESG ratings are changed by MSCI and they're pushed in their systems. Once that's done, those asset managers receive them. They have an ESG team working on them, looking at them, changing them, or re-aggregating them in their own way. And then they're pushed to the fund managers. And the fund managers they want to minimize transaction costs. It takes them a long time to integrate that. And also, tracking error. So we don't have a pre-trend. That's a good news because that means it's always kind of not approved, but it's a condition that it's causal. You see that upgrades increase holdings on the firm level and downgrades decrease it. We see the same pattern with returns. That's the surprising part because you would also think that efficient market theory, that should be immediately, right? So it looks like, and we are still investigating that, but the hypothesis is that those positive returns we observe with here actually due to price pressure. So it's a question of demand. Demand goes up because ESG funds buy stocks, and so the returns go up or go down when demand goes down. And again, time horizon is very much similar. You have all sorts of robustness checks in the paper. I don't want to, bore you with that. But I invite you to read the paper if you want. So this is this paper. And now I will conclude. I won't tell you anything new. ESG ratings are complex constructs. You have to understand them. You can't just use them and then complain that the data is bad. Really have to make your due diligence. You have to make sure that you are comfortable with the materiality, so the scope and the weight, what I said. So what do you integrate in ESG ratings? Relatively important the indicators are. And you also have to be okay with the different measurement practices. As I said, True Value Labs will just do web scraping. And so you have a very high daily variability. S&P Global will send a questionnaire. Those, and then inevitably would come to different conclusions. The second point that I want to take with you is that ESG ratings do contain a signal. And just because something has measurement error doesn't mean that it's not valuable and that we shouldn't use it. We have to know how to use it, and we have to use it in the right way. Last but not least, no standardization. That's something I hear often in talks, especially in Europe. I'm fairly frequent exchanges with regulators in that space, with ESMA, European Commission, and all sorts of other regulators. And yeah, standardization is not a good thing because, first of all, as we saw, more than half of the disagreement is measurement error. It implies we do not, and we also have this very high noise to signal ratio. That implies we don't know how to measure a lot of these things actually perfectly. So standardizing would mean that we just now stop innovating, because why would any ESG rater innovate if you standardize the measurement methodology? And since it's not perfect, it wouldn't be a good thing. It would also create the problem, since it's not perfect, it would create the problem that companies would start gaming those ESG raters. For example, if I measure labor practices in a certain way, in a standardized way, and you would certainly have labor accidents in that standardization, then it's probably the way you measure it would be how many people go to the doctor within a factory. And obviously you would the factory worker or the manager of the factory would start sending them to the nurse, for example, and declare it as a minor accident, that it's not in the category. Those things happen. And so that is how they would start gaming, and as for every indicator they could game them. Yeah. And almost half of the divergence is actually, so less than the measurement divergence, but almost half is an expression of preferences. Scope and weights, so the materiality, is just an expression of different preferences. And everyone is entitled to their own preference. If I asked here how would you weight between 0 and 1 lobbying practice and climate change risks, then we would get as many, and that was a continuous variable, then we would get as many answers as people are in here. And that we shouldn't standardize. Also, those preferences evolve. I think of the death of George Floyd, Black Lives Matter. Climate change in the last 10 years changed completely. How often we talk about that in the media and how important it is. Yeah, and so that is something we shouldn't standardize. And that's it. Thank you for listening.